Okay, let's move to the next slide. All right, well, I started with introduction of Will. I mean, you can go on and on. So here's more information on this slide. I met Will personally in 2008. 2008. This was my first conference as a PhD student. It was in Milano. It was BPM conference. I don't know what edition, like 5th or 6th edition. Now we are soon, well, 20 plus edition of BPM conference, Business Process Management Conference. 7 years ago, we'll introduce Process Mining Conference, International Conference on Process Mining. In a couple of months, we'll have 7th edition. So, I mean, Will is active in not only in academia and industry, but also in service roles and providing opportunities for young academics and shaping the field. So Will started his work in Eindhoven. Originally, he's from Netherlands. He worked in Eindhoven at the TU Eindhoven. And then in 2018, he was awarded Alexander von Humboldt Professorship, which is the most prestigious research award in Germany, and moved to Aachen. And now he is professor at RWTH Aachen University, where he leads process and data science research group. And I had privilege to visit Wills, I think twice by now, there in Aachen. And I can talk on, and I don't want to delay it by much. Yeah, so please join me in welcoming Will. Will, please tell us about process mining.
Thanks a lot, Artem. So we are a bit handicapped that we need to do the slide transition manually. So this is not my dog. Our dog looks very different. Yeah. So thanks, Artem. It's a great pleasure to be here. There are also people like Marcello here that have a background in process mining, and it feels like there are many children. So perhaps a nice fact is that Artem's promoter, Matthias Weske, was also for a short period in Eindhoven before he moved to Potsdam, where Artem did his PhD. So today, I think some of you are new to the topic of process mining. There are also people that have a long history, so it's always a bit difficult to talk from such a mixed audience. But my basic idea is to talk about the developments of the field of business process management, what process mining is, what is object-centric process mining, and what are the most important innovations in the field and how that is enabling AI. So let's move to the next slide. So if you talk about processes and you think about the production process of cars, for example, it is very visible what the process is, right? You see things moving, and if the conveyor belt stops, you have a hunch of what the problem can be. Next slide. But if you look at many other processes, processes in hospitals, processes at universities, possible processes in banks, right? If you go into a bank, there are lots of processes, but you don't see them, right? They are hidden in information systems. People are doing stuff, but you cannot see it. And process mining is the technology to make visible what is actually happening, and then finding out, okay, where are now the problems in these types of processes, right? So that's the motivation. We are focusing on processes. In many cases, people think that they know what the process is. If you go to a car factory, you will also see that it's not so easy there, right? But even in financial institutions, etc., it's much more difficult. Next slide. So I started as a process modeling person, a BPM person. And I strongly believed that workflow management technology would change the world, right? That any organization would use workflow management technology. Next slide. So for example, a kind of fun fact is that there are many younger people here, but like Windows 95 was the first operating system that actually had visual elements in it. But at the time that Bill Gates was presenting Windows 95 at the CeBIT in Germany, which is the biggest computer fair in the world, there were already over 80 workflow management vendors. So this idea okay, you just model a process and then you push a button and then you get an information system that automatically does it, was already there. And it's kind of fascinating to think, if you see what the status of the field is today, that we are still struggling with exactly the same problem. So we want to make sure that processes run well. And the idea of all of these vendors was you just model them, you push a button and you get the system and things will work out the way that you want them to work. Next slide. And at that point in time, I was very enthusiastic, writing all kinds of books on workflow management technology, and I was a strong believer, right? But after a few years, next slide, I started to realize that this was not so easy. So what you see here is a part of the thing that was very popular at that point in time, that is the SAP reference model. And this is an example of the process, what happens if you are hiring a person, right? And like it's not important that you can read it, right? But this people thought this was very important that you would model this, but this model is complete nonsense, right? It has nothing to do with reality. And this model also has lots of internal inconsistencies. So if you look at this model, and I said I will not go into detail, here you in a way see two objects flowing through this process model. You see an object flowing through it, which is a vacancy, and you see people applying, right? And these are two different things, but because that would be too complicated of showing this, they merge that into a single diagram. And if you look at one of the points in the middle, if you go to the next slide, I think it's highlighted, there you see where the application and the vacancy and the applicant come together. So this model is complete nonsense. And still we believed that, okay, if we make our models better, then something like this will happen. So I realized that this was not working. Next slide. So I tried to reverse it, and I started to think of this in terms as a Petri net problem. Given enough data, can we automatically infer a Petri net which is describing what is happening in reality? And that, let's say, kept me busy. At the end of the 90s, we defined the first research projects in this area. And the goal was now not to start with modeling, but to start with data, as you can find them in information systems, and automatically generating these models, right? So that is how this field came into existence. Next slide. So if you look at this pyramid, then if people are talking about business process management, right? I just had a lunch break with lots of representatives of different consultancy firms here in Melbourne. If people talk about processes, they always talk about, I don't know, processes as if they are very clear what they are. But if you look at this pyramid, most of the processes that exist do not even have a name, right? People that are working, they are doing all kinds of stuff, and it doesn't have a name. Then you have, let's say, processes that have a name but have no description, right? We can refer to it as a process, but somehow it is out there and nobody exactly told people what to do, but it somehow emerged. Then you have the processes, what is called here passively managed. These are the processes where at least there is a description. It could be a process model, but it could also be a textual description. And then there is the tip of the iceberg. These are the processes that are called actively managed. So they are supported actively by an information system. And you can think of a workflow management solution, but you can also think of a system that is really being monitored by a process mining solution. And this is the problem, that if like consultants and everybody is talking about this, we always talk about the tip of the iceberg, where in reality, like most of the things that are happening in organizations do not even have a name. Next slide. And of course, our dream is to go to turn around this pyramid, that we have much more processes that are actively being managed. But this is not so easy. So this is the goal of the field of business process management. And you can see that there has been a shift of the field going from automation to, okay, let us first better understand what these processes actually are and start with the less ambitious goals. Next slide. So that's BPM. Now let's move to AI. Next slide. And here, like we are here in Mantler, I'm the Chancellor of the University of Melbourne. it often takes more than half a year to handle travel reimbursements. What should I do to make this go faster? And this is not an academic example. I've convinced finally my university to use process mining on the primary processes. And in Aachen, it actually takes half a year. After people have traveled, they have submitted all the forms and all the documents. It takes half a year to process it. Next slide. So a ChatGPT starts, if you ask such a question, it starts spitting out, let's say, pages with text. Next slide. More text, right? So it says now, if you want, I can sketch you a current versus ideal process map, etc., etc. So it's ends with a suggestion to do. And I say, yes, please do. Next slide. So then it gives an answer, and this is a bit like there are two processes that are doing that, but after that I asked it to visualize it next to each other. So next slide, and this is what it generates, right? So not just the layout looks horrible, that's not the point. The point is that it doesn't know anything about my university, it doesn't have any facts, but it starts, I don't know, spitting out random stuff, right? And the question is this useful? And of course, this is impossible. So later I will talk about the role of AI in process management, and you can see that this is absolute nonsense. There are many people that today would like to believe, okay, you just write something in ChatGPT and you're done. It doesn't work like that. Without the actual data about the processes, you cannot help organizations in doing this. Next slide. So this, the point that I'm trying to make is that you first need to do process mining before you can apply AI at an enterprise level. Of course, you can use AI to automate all kinds of tasks, right? You all have a mobile phone and AI is everywhere, but it's just for a single task, often involving text. If you look at the organizational processes, think about the movies that I showed at the beginning, what is happening in a hospital, what is happening in a car factory. You need to provide it with information in order for AI to give meaningful answers. And the better this contextual information is, the more effective AI can be. Next slide. So with object-centric process mining, it has many different drivers. It makes the process mining itself much more powerful, but it also provides the context for the AI to work because you provide it with better types of information. Next slide. So I'm now going to talk to you what is case-centric process mining, the classical form of process mining. Next slide. So what you see here is event data. This is about the order handling process, and you don't need to understand the details, but every row in this table is corresponding to an event, something that has happened. So in this example, you see events like making a delivery, sending an invoice, making a payment, these typical business activities, all related to an order. If you would go to other domains, for example, a hospital domain, what would you see? You would see, for example, a patient getting a blood test, a patient, I don't know, getting an X-ray, a patient having an appointment with the doctor, etc. If you go to your local bank, right, you would look at the events there. That would be, I don't know, that you open a bank account or that you close a bank account, these types of things. Next slide. So what is the minimal information for process mining is that for every event, you should know when it has happened, timestamp. You should know what has happened, that is the name of the activity. In this example, send invoice, place order, and all of these things. In a medical domain, you would see things like take blood test, take X-ray. In a banking situation, it may be that the customer files a complaint, something like that. And the last thing you need that's in this column is the, let's say, case identifier. And in this example, it's referring to an order number. In a hospital setting, this would, for example, be the patient ID. Next slide. So with this information, you can automatically generate process maps. And if you look at the most frequent behavior, so for example, you look at patients and you look at what is the path that most patients follow, we get something that you call the happy path. And here you see, like in our order handling example, you see a sequence of activities. And this is like if the order is being processed without any issues, right? And you can look at the frequency of that. Next slide. So, of course, you know that it will not always work like that. So if you start also looking at things that are still very frequent, but have a lower frequency than the most frequent path, you see something like this. So now you see things like, for example, a step approved credit check that apparently not always happened. Return goods and cancel order is another path that you now see emerging. And this is at a level, I was earlier talking about workflow management technology. People that were trying to configure these workflow management systems, they were AI. People that were trying to configure workflow management systems, they were thinking about processes at the level that you see here in the middle, right? This was what they would model. And then why did workflow management technology fail? Next slide. That is that in real processes, it looked like this, right? So you see all the exceptional behaviors. So what you see is that there are paths that are super frequent, but many of these processes have a very long tail. So at the end, most of the executions that are at the lower end are unique. So for example, yesterday there was the Celonis Process Intelligence Forum in Sydney. There were people from Queensland Healthcare, and they have saved 11 billion using process mining. And one of the things that they said that is they found out that they had 80,000 different ways of ordering stuff, right? And that provided lots of opportunities for improvement. And 80,000 is not a lot. If you would look in a company like Siemens and you would look at all the order data over 1 year, you would find 800,000. So 10 times as much. So this variability, this long tail, is showing what is happening in real life. And if you try to squeeze it into a workflow management system, like the level in the middle, you're missing out of a lot of behavior. So this is, let's say, why process mining is important. Next slide. So just click a few times that we, yeah, one more time. Yes, you can stop here. So if you now compare these two worlds, right? What the world that you would typically model, on the one hand, you could say, yeah, this model is good because it's covering 80% of the cases, right? To add the remaining 20%, you get all of this complexity. So if you think about this naively, you would say, yeah, screw the 20%. Let's just focus on the mainstream behavior and focus on that, and then we are done. But the mistake that you're making is that all of the inefficiencies, all of the compliance issues, where all the cost and energy goes, is not in this 80% model. It is going into the remaining 20%. And this is showing why it is crucial to be willing to look at this complexity. I hope you also get a feeling like if you now think of AI, etc., that you cannot expect magic if you're not willing to try to understand what is going on in your processes. Next slide. So perhaps I'll also click here a few times. One, yeah, one more, yeah, good. So if you look at the triangle of process mining, what are the things that are happening? It starts with the extraction of event data from these enterprise systems, the university information system or SAP or Oracle or a hospital information system like Epic or something like that. You extract data, then you first try to discover what is really going on, looking at the spaghetti diagram, realizing that reality is much more complicated than you think. That often generates already lots of positive effects. Then if you look at two, what is called check here, which we typically call conformance checking, then you're no longer looking at discovering what is going on in your organization, but you have an idea of what you would like to happen. And then process mining is analyzing the differences between what you would like to see and what is actually happening. And we call that execution gaps. So what are the differences between what is supposed to happen and between what is actually happening? Then if you have enough data, right, if your processes are relatively stable and there is lots of repetition in it, you can also go for predictions. If your process is different every day, don't try to do that, right? The predictive value will be very low. But if there is lots of repetition, you can use that. And in all cases, you would like to actually change processes. So if you're using a workflow management system, the more mature organizations, they are looking at these execution gaps. And for every, let's say, important execution gap, you generate a workflow each time these inefficiencies are happening, right? And you try to address them. And it can be as simple as sending just an email to a manager, hey, something is going wrong again. It could be as simple as that. But it can also be that you automatically, for example, remove credit blocks in your SAP system or whatever thing you have in mind. So for example, for the people that do not work in industry, you would be surprised how many organizations are paying invoices multiple times, right? Organizations can save millions and millions of euros by not paying things multiple times anymore, right? And that sounds very surprising, but that's where you start with these low-hanging fruits. Next slide. So this is sketching a bit the history. As Artem indicated, this all started basically in Eindhoven in the late 90s, where I became head of a new group and I had to think of a new, let's say, research line, a research topic. At that point in time, there was also somebody called Ton Wijters in the group who had a background in machine learning, and that kind of led to the development of this area. And in the first 10 years, there were very few people all around the world working on this. So a few of my students started, let's say, around 2007, 2008, 2009, started process mining companies. Some still exist, like Fluxicon of the Disco software. Other ones, the first one was Futura Process Intelligence that was sold for a lot of money to Lexmark and then completely destroyed, right? So you cannot use it anymore. But he is rich, so he's happy with it. And in 2011, also Celonis, let's say, was founded. And the idea of these software tools was to bring these academic ideas into industry, right? Which was very useful. If you look today, there are many workflow management systems available, right? There's a lot of things that you can choose from. And what you also see is that the adoption is increasing. But adoption is not equally distributed over the whole world. Right? So if you look in countries like the Netherlands and Germany, etc., you can see that there's a lot of knowledge and there's a higher adoption. Many of the, so for example, all the Western car manufacturers are using process mining in some form, right? So on the one hand, there is this adoption. On the other hand, there are many organizations that do not even know that it exists, right? Probably if you walk into a random larger organization in Australia, you need to explain what it is, right? Although it's a proven technology that's easy to use. So the field developed. There are now dedicated conferences on process mining like ICPM. And also if you go to business process management conference, there are multiple of them. You would see that half of the papers are about process mining. Next slide. So this is, for example, reflected in something like the Gartner Magic Quadrant. And so Gartner is one of these analyst firms that is kind of analyzing what happens in the market. And most of these larger analyst firms, they are now recognizing process mining as a separate category of tools, right? And there are around 50 tools available. And here you can see the ones that are meeting certain criteria, right? So there are criteria, for example, with respect to revenue, and people and the organizations also need to share some data in order to be in this Magic Quadrant. So as chief scientist of Celonis, I'm of course very happy with that. But being here, it's also important to mention Apremore, right? Which is the tool that was first, the development started at QUT in Brisbane and then moved here to Melbourne. So I'm showing you this to show that this is now, the tools are there. It's a mature category of tools. Everybody in principle can use it and you can choose from things. If you look at the Gartner report, there are two things that I would like to highlight that were then trends that were identified that I would like to relate to. One trend is very obvious, right? AI, also the uptake of generative AI is impacting also the field of process mining. The other thing is that for more complicated scenarios, you need to use object-centric process mining. And the main statement that I would like to make today is that I hope that you will remember is that if you do object-centric process mining, you have a much better chance of using process mining in more complicated scenarios, but you also have a much better chance of equipping AI with the knowledge that it needs to have to give meaningful answers. Next slide. So object-centric process mining is now the next topic. Next slide. So what I changed compared to before, that's the easiest way to explain it, is that in object-centric process mining, you get rid of this case notion, right? You no longer need to relate an event to an individual case. You can relate an event to any number of objects, right? So if you take an example, if a customer places an order consisting of multiple items, then you have the object customer, you have the object order, and you have the items that are being ordered by the customer. Later, the customer will get an invoice, right? There may be multiple shipments. There may be all kinds of things that are happening that are involving multiple objects. And this is very important to capture this. Also, if you would go to a hospital setting, you can say, okay, I reduce my processes to just looking at what happens with the patient. It's very naive, right? Because patients are competing for resources, like medical devices, doctors, etc. Right? So there are many more. Also, if there are test results, you can also think of these as objects, right? So it's not so simple. Right? If this case-centric view would be sufficient, then many information systems would just have two tables, right? And that's not the case. If you look at the system like SAP, you have 800,000 tables. So apparently it's not so simple. And object-centric process mining tries to address this complexity. Next slide. So this is a visualization, right? You can think of any production process is producing products that typically consist of multiple parts. So if you have a car, it has an engine, it has tires, etc. So if I now would like to analyze a production process, so for example, if I order my new Porsche, it is assembled to order, right? So you place an order, and based on your order, the car is being painted black, it has this engine, etc., etc. So it is being assembled based on the request of the customer. But at the same time, many of the parts are already there before the customer actually ordered something. So if you would now think of this as a process, where does the process really start? Does it start with my order? No, of course not. Many things have happened before I ordered the car in the first place. So this is showing that anything where you build something consisting of multiple components, you're in an object-centric world. And trying to reduce this to a single thing would be super naive. Next slide. Here's my favorite example. Lufthansa is a customer of Celonis. And Lufthansa is using, let's say, process mining for the boring processes, like finance and stuff like that. But they're also using it, for example, to find out like lost baggage, like where the bags are, etc. And then it becomes already for you as a customer more tangible what it's doing. But what is also happening is that Lufthansa is monitoring in real time all the activities that are happening at the Frankfurt airport and Munich airport. So at these airports, planes are landing and taking off again. And it's amazing to see what kind of events are available, right? So there are events like baggage loading started, baggage loading completed, people start onboarding. You see all of these activities. And if you think it a bit further, right, they did not fully adopt the object-centric thing, but every bag is an object. Every passenger is an object. There are people standing at the check-in desk that are first standing at the check-in desk, and you later see them at the gate again, right? So if you think about it, it's a very complicated process that involves many things and people and concepts that are all interacting with each other. And in these processes, it's very easy to imagine if you look at the flight, if one of these things goes wrong, everything is destroyed. I think everybody has the experience. The plane has landed, but you're waiting for the stairs, right? And just because the stairs are not there, that plane gets delayed and is creating chaos at other airports. And this is what is happening in many processes. Next slide. So to make it a bit, let's say, closer to home, think of you ordering, let's say, stuff from Amazon. So in one order, you can, so these are the orders. In the middle are the items, and on the right are the packages. In one order, there can be multiple items. And now the interesting thing is happening. Some of the items that you order may be in stock, and Amazon will deliver it the next day. Other things are not in stock and may, for example, take 2 weeks to be delivered. Also, if you have 4 children, like we have, then there are multiple orders placed per day. And what is very funny is that often in the packages that you get, you have items that actually originate from different orders. If you order enough, then that is what will happen. So now I try to look at this as a process mining problem. And if I would use case-centric process mining, then I would need to choose what is now my case identifier. Is it the order? Is it the item? Or is it the package? Next slide. So if I would consider all of these things separately, right, I would just look at orders, I would just look at items, I would just look at packages, life would be very simple, right? So place order, confirm order, then there may be multiple payment reminders, and I pay the order. But all of these things are related, right? So if I place an order, right, that doesn't only affect the order, it is also affecting, let's say, items, right? What you see, if you look at the numbers carefully, you will see that every order on average has 4 items in it, right? So and items can be out of stock. At the end, you have deliveries, and there you see different numbers there because, I don't know, items from different orders may end up in the same package, and in a package there may be things from multiple orders, right? So this is very simple, but it's also looking at every object as a siloed thing. So object-centric process mining tries to address this problem by looking at the real data, the real frequencies. Next slide. So what we do is that we look at what has actually happened, which objects were involved, and then you get process models like this. So if you now look at place order, it happened 2,000 times, involving 2,000 order objects, but in total 8,000 items. And if you would look at the statistics, then you would see on average in an order there would be 4 items. If you look here at create package, there are in total approximately 1,300 packages, and in these 1,300 packages there are 8,003 different items. So this is looking at the world of different objects involved in activities. Next slide. So that is hopefully like a practical example which shows you why this is important. But now I'm showing you a synthetic example to make it even more powerful, that you believe that you need multiple objects. You cannot see anything here. I named the activities A, B, and C, right? But this is an example of an object-centric event log. So in every row still corresponds to an event. It has a timestamp, but it can involve different types of objects. And of course, your brain hurts when you look at a table like this. So if we go to the next slide, then you will see it like this. So now time is passing from top to bottom. And every of these colored lines is corresponding to an object. And we have the blue objects, the green objects, and the purple objects. So to make it more, let's say, intuitive, you can think of the blue objects as my orders, the green lines as my items, and the purple ones as the packages, right? And I'm trying to create a minimal example showing this. If you look even more carefully, you will realize that every object follows a strict sequence of activities. So if I try to discover a process model per object type, next slide, then I will see something like this. So here I have 3 process models. And I just, so if you look carefully, every line of a particular color follows exactly the same sequence of activities. And I just gave them names in such a way that that is not difficult to see. So every object is following exactly the same sequence. But what you see, if you look, for example, at the top of activity B, it is involving 1 blue object and 3 green objects, right? So if I look at this, it's not very informative. I still have no clue what the real process is that is happening. Next slide. So what you also see with the dashed lines, I'm trying to indicate, for example, if you look at B, it is involving 1 blue object and multiple green objects, right? And you can see that with the dashed lines. To merge these models together, I need to make sure that all of these different object types are agreeing on the frequency of how often it has happened. And this is not difficult because the real frequency is in the data, right? We know what happened in reality. So this allows us to kind of merge these models into one model, next slide, that looks like this, right? And this is super abstract, but what you now see is that you see the different colors correspond to the different object types, and you see one pretty readable process model where you can still see the sequential structure of these different objects, right? So this is an object-centric process model. But now, let's say smart people will say, yeah, it doesn't make sense to look at all of these objects in isolation, but we have a case-centric process mining tool, so we have to do something with it. So let's, for example, squeeze the green objects into the blue ones. And how can we do that? We can do that because every green object, an item, belongs to an order, right? So if I look at activities for an order, I can also look at the activities happening to the items inside the order, right? So that's the way how you can squeeze it into this case-centric view. Next slide. Right, so this one, next slide, please. So what if you look at here, orders plus items, so I take orders as a case ID, and I squeeze everything that happens to items into the order, and that makes sense, right? Because every item belongs to an order, we get spaghetti. Let's try to be smarter. We try to do the same we take packages as a case identifier, and we try to squeeze the items in, again, spaghetti. Let's then take a look at the last possibility. Let's take the one in the middle, and please realize that every item, every green object, is corresponding to exactly 1 purple object and 1 blue object, right? So it's very easy to make that into a single case, right? And people will also do that. And then you get the one that is on the right-hand side. So in other words, if you try to squeeze it into one thing, you always get spaghetti, right? And please remember that for every object, there was just a fixed sequence, right? So this was the simplest scenario that you could think of. So hopefully this shows you that if you do case-centric process mining, that there are certain limitations that you run into. Next slide. So in our research tools and also in the Celonis system, we are now using object-centric data as a starting point for everything. So we are loading, let's say, these object-centric data together with KPI computations and all of these things into the system. And then we can do discovery. And you don't need to understand the details, but like with the different colors, you now have like a mental map. Okay, these are models that talk about multiple object types into a single diagram. And we can also do classical things like conformance checking, right? So if you know what you want your process to be, you can just model it and then check, okay, is reality really happening in the way that you would like to see it? Next slide. And these are some other visualizations. So you can do conformance checking, and the conformance checking is talking about multiple objects at the same time, right? So you can see diagnostics like this. Next slide. You can also look at performance. And now I can relate to, let's say, this example of orders, items, and packages that I used earlier. What you're interested in, if you place an order, when is the last item being shipped? right? And if you look at my order data, I could not see that. I need to go from order to item to shipment, right? So I need to relate these different objects. And that's what you see in this graph, right? That we are looking at performance in this more richer setting. Next slide. Click 2 more times. Yeah. So to summarize, what are advantages? If you do this, your data is much closer to reality. You only need to extract your data once. In the case-centric view, each time you want to take another, another view on your data, you need to go back to your systems. So you only need to extract once. You don't have these distortions of these spaghetti models that hopefully I showed to you. And so things that are completely sequential remain completely sequential. And you can see problems that are involving multiple object types at the same time. So for example, if I would like to know my OTIF score on time in full, then I need to relate different objects in order to do this. Next slide. So this is the time now to talk about AI, right? So how does this all relate to AI? And I hope what I tried to explain in the beginning, you need to provide the AI with context. And this object-centric event data is the context that is about processes in the purest, let's say, generic form that you can get it. Next. So we have seen this. This doesn't work. We now want to use the data. So if you talk about AI, like the term is heavily overloaded, so things that were called data mining in the 90s are now called AI. But basically you can distinguish between classical machine learning and you can look at generative AI. I think these are two things that are very different. If you look at classical machine learning, and this could also be traditional data mining techniques, you will see that in order to apply machine learning or a data mining algorithm, you need to provide it with structured data. Where does that data come from, right? How do you at all generate the data related to a problem? And what you see there is that event data and process models provide the lens to look at such data in order to answer these types of things. So without a process model, you do not even have the language to express yourself like what the problem would be that you would investigate. Perhaps this is better visible on the next slide. So for example, you can look at a process model, and in the process model you see deviations, you see bottlenecks, you see the places in the process where you are losing your customers. And so for each of these problems, which we call execution gaps, you can generate, let's say, the input for machine learning data, right? And without this process model and event data as a lens, we would not be able to do this. Next slide. So here are some examples, right? Just to illustrate the types of questions. So you see a bottleneck, and then you use machine learning to explain why it is there. You see a frequent deviation, and you try to find out what are the objects, what do they have in common that have this particular deviation. Right? So all of these questions can be answered by a combination of process mining and machine learning. Next slide. Of course, there are many applications for something like that, but many people in practice say, yeah, this is too much work, this is too difficult, let's use ChatGPT because that can do anything, and they do this. But based on, if you do this, you will just have guesswork, right? It will just guess something. So what is a way that could work? Next slide. Is that you are using these process mining capabilities and the structured information to inform the generative AI to deal with this in a smart way. So how does that work? If you're using a process co-pilot, the way that it works is that the Gen AI gets a question, but that's not the only thing. Next slide. There are many animations here, so it's challenging. So the process mining layer is telling to the Gen AI, we have these object types, we have these event types, we have these capabilities. I know what an OTIF score is, right? So you provide it with all of this information, which is available thanks to process mining. You can also talk about deviations in an informed way. that layer is telling to the Gen AI, these are all the things that I can do. And then the Gen AI is smartly combining that textual question with the capabilities. And then it starts, let's say, what's called query here. So it's using process mining capabilities. And this will go through multiple iterations. Perhaps you can click a few times. Yeah. And in that way, you get an answer. And important to realize that if you get an answer in this way, it is a computation, right? It helped you to translate a natural language question into a computation that you can inspect how it has been done, right? And this is no longer guesswork based on Wikipedia, but on your actual data. Next slide. So if you look at the Celonis Copilot, this is what is happening, right? And Celonis is not the only one doing this. You can compare this to ChatGPT in the beginning, not using a calculator, right? When you were using ChatGPT in the beginning, people that started using it earlier, it had this very funny mistake. You would ask it very simple mathematical questions and it would give the wrong answer because, of course, it was not trained on all possible combinations of numbers, right? That would never work. So today it is giving you a perfect answer each time. And the reason is it is no longer using the LLM to do that. It is using a calculator. And the idea here is that instead of using a calculator, you're using a process mining engine as a kind of calculator that can do anything related to processes instead of numbers. Next slide. Next slide. So that was the Gen AI part. Here I blend in the part that I was talking about earlier, classical machine learning. I think there are lots of opportunities. I think there are also lots of opportunities to combine process mining with classical operations research methods, optimization, etc. I think there are lots of possibilities not being used today because companies are missing this process mining part in the middle. And that's why they cannot apply these types of technologies. Next slide. If we think about Gen AI, so where it could help us more is, of course, it can help us to make easier to extract the data. And so, for example, if you're using ChatGPT, it can easily generate a query for you. It can also, for example, if you have data that is partially textual, for example, you have a ticketing system, a ticket is created, it has a date, it has somebody who has created it, but it will also contain a text field. And you can ask ChatGPT, okay, give it one of these three labels, right? And it will be statistical, but you will turn it into structured data. Next slide. And on top of that, today many people are talking about intelligent agents. I think Artem will also talk a bit about this. So the reason that I'm showing it like this, also an intelligent agent can only make an informed decision if it has these types of capabilities, right? If it's anything process related, it needs to be provided with information in a structured way. Next slide. To come to a conclusion, next slide. I hope for the people that are there, I think there are a few believers here that believed it before. But for the people that are new to it, you will think, why is not every organization doing this, right? Why did it take a couple of years for me to convince my own university to start using it, although the problems are obvious? Why is in the city of Aachen, where I live, right? A very funny anecdote. So I was lecturing my class on machine learning, and I was asking the students, how many people do you think work in the administration of the city of Aachen? The city of Aachen, the university is huge, like 50,000 students, but the city itself is just 200,000 people. And one of the students in the first row raised his hand and he said, I think there are only 3 people working in the administration of the city, because if I'm asking for this and this and this, I never get a response, right? So everybody had to laugh. And then they said, no, in the city of Aachen, again, a city of 200,000 people, there are 6,000 people working in the administration, right? So, and this is what you typically see, right? I was giving a similar talk at the University of Bolzano. Also, the rector was there. And in the University of Bolzano, there are more people working in administration than there are academics, right? I'm not sure what the ratio is here in Melbourne, but it shows that there are lots of opportunities for, let's say, efficiency gains. But what happens, next slide, is that people will say this, right? They will say, yeah, this is all very nice, it's all very logical, but don't bother us, we are too busy, right? Handling travel declarations or whatever thing they are doing, right? So I think, yeah, I give often these types of talks, trying to change, let's say, the world that they should use this, right? This is the only way to improve processes, by starting to look at the facts. Otherwise, we will repeatedly make the same mistake again and again. Next slide. So to summarize what I've been talking about, process mining is a very mature technology. It does exactly what it should do. Object-centric process mining allows us to look at much more complicated scenarios. It also enables us to inform AI with, let's say, very structured information that the AI can then use to make informed decisions. That's why we often have the slogan, no AI without process mining or without BI. This is very important. At the same time, where are the biggest hurdles? If you go to let's say, practice, that is that people do not know about it, that people say, like our data quality is too low, we cannot do that, which is often an excuse, just like data privacy things. It's often an excuse. People are always waiting for something to happen in the future when they do that, but it's important to start today. The third thing is that process mining creates lots of transparency. And you can imagine that not all organizations, not all people in organizations are super happy about this. Right? That's why the challenges of making this work are not so much anymore in the technical challenges, but it is in making this work in the real world. Thank you very much. Do we do questions or not?
We have time for a couple of questions. Yes.
I will. So I used to run payments for the bank here, and one of the things that, going to the very last point about transparency, I couldn't get anything onto the chief risk officer or the chief operating officer's table, because once it's lands on their desk, they have to do something about it. Okay. Is it on? Yeah. Okay, so in terms of transparency, once you hit the chief risk officer or you hit the chief operating officer, they will only let it land on their desk if they can fix it. So yes, it's great that we can get this level of transparency. What have you seen in terms of the abilities of the new tools to be able to help resolve that underlying complexity and simplify it? Are we any closer to sort of being able to make that journey easier or just more transparent?
I think that is a real world problem that you are indicating. That's also why you see that, like I was telling a bit about the history of my students starting process mining companies. I think the mistake that my, let's say the early companies that started doing process mining, I think they were too often at a level, they were entering the organizations at the level of a data scientist or something like that. And from experience, that doesn't work. You need to have, let's say, top level support, realizing, yeah, it is now time to change the square wheels. We can no longer do that. There has to be a sense of urgency. I think tooling is not helping you in this way, right? So tooling, what I see, if I look at the practice, something that has completely changed is that, let's say, companies like Celonis, but also the others, they are very systematic in, let's say, proof of value projects, right? So what you often see is that there are projects that are just running for 3 or 4 weeks, right? Where the company does not pay any money, right? The company does not pay any money. The project is done. And then if it is shown that the data is showing there is this potential to save so many millions, then after that point in time, the company starts paying. And that these savings are made very explicit and are kind of also advertised. So that mechanism works, but that's not like that the tools are very different. It is going very systematic about it. It should not be a hobby project, right? you need to prove the value. But if you look at the spaghetti-like diagrams, there is lots of untapped value that you need to approach in the right way. But there will always be resistance, and that's completely logical.
Yeah, thank you for the presentation. Very, very interesting. I have a question about the availability of object-centric event logs, like public event logs. I know there's database for case-centric. Are there any plans or any existing databases for object?
So in the process mining community, there are efforts on, let's say, standardizing, let's say, object-centric event data. So there is like a working group that is working on this, but as with most working groups, it is very difficult to get to a consensus. What we did is we defined first the OCL 1.0 standard and then the OCL 2.0 standard. That is a standard for storing these type of data. And that standard is also kind of consistent with what this working group is doing, but very pragmatic. So what you see there is that there are, let's say, 4 possible formats. It can be a database format. It can be an XML format. It can be a JSON format, or it can be, let's say, a graph-based format. So for these formats, there are multiple data sets available that you can go. So if you go to the OCL standard website, you will find some data sets. The difficulty, but that has nothing to do with object-centric, the difficulty what we witness is that many of the let's say, publicly available case-centric event logs were presented before GDPR. Since GDPR has been introduced in Europe, it has become close to impossible to share, let's say, industry data, right? What companies before GDPR, they would do it. Now it is extremely rare that companies are willing to do this. So data sets are available, but they are not as real as they were before. But this also does not have to be, let's say, so much a problem. So I think in research, we should now learn from these experiences and go much more to a mode where we are generating synthetic data, which resembles real world data very accurately to get rid of this. Because at least perhaps in Australia it's easier, but in Germany you will not succeed in publishing data unless, so we also, for example, one of my PhDs analyzed several online games, right? And then we take these data sets and we turn them into object-centric event data, just also to have data sets that are like huge, so for scalability types of things. But then these are not the processes that we would like to target and that provide valuable use cases. Yeah.
Thank you.
Maybe we have time for one more question. We will end at the back, and then of course we'll have networking event.
All right. Thank you again for wonderful presentation, and congratulations for doing a good job with the limitations on not being able to control your slides. My question's a little bit...
It helps if you know your slides, actually.
Oh, yeah, it really does. You made it look seamless. It almost looks like they were in conjunction with you. But you mentioned that, and it's very clear in the presentation, that this will really work in a scenario or an environment where there's tons of complexity. And it makes it, I think, a bit more approachable, notwithstanding some of the real life challenges that we heard about. Is there a way that this product, this approach has been used with companies who have not yet reached that level of complexity in almost a preventative manner? This is how you would actually go about doing this so that you don't end up needing to unravel such complexity in the future?
So the interesting thing is that if you look at, let's say, case-centric versus object-centric, is that it is easiest to convince people that are not used to case-centric. Because many people have been blinded by their whole education and the way of thinking. Like, if you think the BPMN modeling part, right? All the organizations are having drawers filled with BPMN models, right? And now what is a BPMN model? You're basically showing how one case, one object is flowing through a chart, right? So that's what we used to do. And then you look at the data, and if you carefully look at the data, you can realize it's complete nonsense. Because in a database, you never see one-to-one relationships. You never see just two tables. What you see is you see dozens of relevant tables for your problem, and the relationships are never one-to-one. They're always one-to-many or many-to-many with something in the middle, right? So there is a complete mismatch between like how people think in terms of processes, this very like case-centric view, and the actual data. So I would argue that if this is done properly, but I also should admit that I see many scenarios where it is not done properly. If it's done properly, it is simpler. And a thing that I should also always mention is that it's not case-centric is not wrong, and you can think of case-centric as a special case of object-centric, right? If you just want to see one color, right, you're not forced to use multiple colors. Also, what's very important to do is that there is a difference between the data that you're loading, that may have a huge complexity, talk about dozens of different object types, and the views that you generate, right? It's like, so we often use the metaphor of an MRI. You make a full scan, not of your body, of an organization. And of course, you do not want to look at all the data in one go, right? You think, okay, there may be a problem there, and then you choose a particular angle to look at that part in detail, right? So I think complexity can be managed, but it has to be done properly. Of course, if people just load lots of complexity and then push a button, discover now the digital twin of my organization, it will just be confusing.
Thank you.
Thank you.
All right. Can we switch the slides, please? No, it's not. AI generated. All right. So I guess I'll pick up from this example that Will gave with 6,000 administration workers in Aachen. Yeah, something is wrong. I hope you agree. And I don't know what needs to happen, but one thing that can happen is that, well, certain roles will be replaced, what is now called agentic AI, right? So special agents that will be doing intelligent work in your organizations and working hand in hand with human workers. So I was, well, less than 2 months ago, I was in Vienna attending Kai's conference, and there was a representative from SAP Signavio, and he was saying, so our sales pitch to our customers now is that we are aiming to augment, it's a politically correct way of saying replace, consultants. So kind of you propose to your organization, so you don't need to hire these expensive consultants. Instead, your HR department goes and hires an intelligent AI consultant, and the price, I mean, depends on how sophisticated and smart that consultant is, and that consultant then loads the data, analyzes, and provides insights. I mean, that's kind of the sales pitch. Are they there? Not. But I mean, it's a good goal, right? A good goal to have and pursue. So today I will talk about bottom-up process mining, which will a bit go in that direction and trying to say how, well, one of possible side effects of this can be that you identify possibilities to automate or to replace certain roles with agentic AI, or find opportunities where agentic AI can work together with human workers, right? Yeah. And so why bottom up? Why bottom up? So, you know, I came to Australia more than 10 years ago, and now being here down under for over 10 years. So bottom up seems like a natural perspective. All right. So next slide, please. Next slide. So I'll start also start with introduction of process mining. I'll give my perspective, and maybe it will enrich your understanding of process mining. So we need to start with an assumption that we all live in the real world, right? I mean, we need to agree with that. Next. And I mean, real world is very complex, and we humans, we designed systems to make our lives simpler in this complex world, right? So for good or bad, right? Again, for good or bad, but we need to face it. They're here, and they are supporting us. They're controlling what happens in the real world. Please click. And when we design this system, so we design process models that specify what this information system, software systems should do, and then describe what happens in the real world. One click, please. And the systems, of course, generate the data. I hope you can spot one problem with this slide, right? Here, data is somehow disconnected, and this is bad, right? I mean, of course, it's a very valuable resource, and that's where process mining came. Next slide. And that was kind of, I think this is the greatest invention of process mining, right? So this bridges the data back and kind of creates this feedback cycle into the whole learning process, right? So we use the data to improve processes, which improve systems, which improve our experiences in the real life. And there are three central problems in process mining: process discovery, conformance checking, and process enhancement. So in process discovery, we take the data and we click a button and we construct a model, what happens in reality. With conformance checking, we have a model, we have the data, and we see where the discrepancies are, where deviations are. Are they good deviations? Can we learn from them? Can we incorporate them back into the processes? And process enhancement, well, if we know some good deviations, we automatically redesign our models, our processes. So that's what the process enhancements problem is doing. Next slide, please. And here in Melbourne, right? I mean, we have a process science and technology group, and we pretty much work in all aspects, and kind of we really address all problems of process mining, process discovery, conformance checking, enhancement. Also look into the prediction, prescriptive aspects of process mining. So I'm really fortunate to lead and work together with these talented people, and you may meet them today. Some of them are here, so please approach them, talk to them, be kind to them. They're really working hard to improve process mining. Next slide, please. So I will again start and kind of explain you what is the oil of process mining, what is the data of process mining. I'll start with the classical case-centric process mining. So over time, and this was not an immediate decision, so community agreed that the minimal information that we want to have for process mining tasks is that we want to have case ID, case identifiers, timestamps, and actions that triggered the events, right? So every row in this table is one event. Case ID, think of it as like a loan application process. Case ID 1 is a loan application process for your home loan application, right? Case ID 2 is your friend's application. Actions, you submit the application, it gets assessed, etc., and there are certain timestamps at which certain events were triggered by those actions. Next, click. And we take in a conventional process mining, we take a case-centric view, right? So then we group those events by case identifiers, order them by timestamp, and then basically we see how the process unfolds, right? So I submitted application, it got reviewed, it got approved, loan was granted, you repaid your loan, you're happy path. And of course, you understand that certain cases can repeat. So you can have a certain sequence of actions, and your friend can actually, by chance, have a similar or very same sequence of actions. And therefore, you can see that certain cases appear multiple times in your data. Next click. And I'll also emphasize one problem of the three that I introduced real briefly. So, but a process discovery problem then takes the data, takes event log, applies some magic algorithms, and constructs a process model that aims to faithfully represent the data. So here I have a model I use a simple notation. In process mining, we call this notation directly follows graphs. So every walk in this graph from node I to node O will be a possible execution sequence, right? So some possible execution sequence of steps. And the real challenge of process mining is that we not only want when we discover a model, we want to represent the event log. What we aim to really represent is a system that generated the event log. So this is a real challenge because we only have a sample of the data. We only have sample of positive examples of what can happen, but we aim to generalize to the entire process. Okay, so this is a problem of process mining. Next click. And now if you do that, we can do discovery of models in different ways. So then the question is, which one is the best way? And what we do, we kind of solve a multi-objective optimization problem. So we say we want a model which has good precision, has good recall, generalizes well, and is simple. Right? So these are kind of standard quality criteria for process models that we discover. So for example, if you say that model is precise, you say that this model is not supporting cases which were not seen in the data. Right? You want to avoid cases that you haven't seen in the data in the model. For example, in this model, you see that there is a small loop attached to task activity E, if I see it correctly from this angle, E, and I mean, that means that potentially I can do E any number of times, and you never see, let's say, in the data that you did E 3 times in a row, for example. So that's penalized precision. Recall, we want to see that the cases we see in the data can be replayed by the model. Generalization, we want to ensure that the model not only captures the log, but also captures what system can potentially support in the future loan applications. And simplicity, so given all other objectives, if they are fulfilled, we want to construct a model which is as simple as possible. For example, in the number of nodes and edges, we want to keep our model to be small. Next slide, please. And I mean, these are expectations, right? So Will said that there are now around 50 vendors, and well, they kind of work in this market. They have all discovery components and they construct models. So these are now 3 models constructed by 2 vendors in process mining. Around 3-4 years ago, I went to these vendors and asked, please, can you construct me some models to compare? And these are the models that are constructed from the raw traffic fine event log. So the data here is, if you committed a crime on a road, you have to pay the fine. These models should reflect the sequences of actions you do when you repay your fine. And kind of, right, so they are simple. Well, I mean, simplicity is a relative thing. Let's agree they are simple. And once you show these models to business analysts, what you want to achieve is that business analysts can understand what is happening and take decisions based on these models on how the process can be improved. Right? That's kind of the starting point of process mining. We want to understand what happens in reality so that we can take decisions on how to improve these processes. Next click. And this slide is very similar to what Will was showing, but reality is very complex, right? So we often end up with spaghetti models. So the one on the top is, I think, from the book on process mining. The one on the right was generated by one of my PhD students. I mean, I asked him, please discover some models. He went away and came back and said, oh, this is a model I generated. What should I do with it? And this is super complex, right? This is super complex. And reality is complex, and Will did a good job, well, also providing evidence that this complexity exists in the real world. And I was very careful looking for some quotes in literature and encountered this quote in one of Will's papers, right? So in one real world purchase to pay process, right? There were, I mean, it's not a huge data set, but well, 2.6 thousand cases. Every variant, so every distinct trace happens on average less than 4 times. So there's a huge variability in real life processes. And this is partly also the reason why we get this, what we call spaghetti models, because they just look like a plate of spaghetti. Next slide. And, you know, so then I thought, okay, I will do some experiment, right? So unfortunately these days I don't have much time to play with the tools, and I said I'll analyze and you know we will also showing that often we can apply this Pareto principle where 20% of causes explain 80% of effects, and I kind of wanted to confirm to myself, is it really so? So I took a real-world data set. In this case, I took a data set which is BPI Challenge 2014. So process mining community organizes challenges, yearly challenges, process discovery contests, we publish data sets and then ask authors of process discovery algorithm to discover models, and then we compare them and determine who is the winner. Right. So in 2014, we had a data set which was looking into incidents in a bank, software department when implementing changes to the software and handling incident requests from the customers. Well, they collected the data set. You see that there are 46,000 cases, close to 500,000 of events, 39 different actions spotted in that data set. On average, there were 10 events per case. And then I constructed different models. So I took the tools, and here I also cite the algorithm. So this is completely reproducible if you want to reproduce this. So you see, I constructed the models. And if I keep 100% of paths, so all traces in my model, I get this terrible spaghetti. The model is huge. Size is, what is it? I don't see from here. Well, 2.something thousand. Model is huge. If I slowly decrease the size, so I filter infrequent traces, well, I can. So if I keep 20% of paths in my model, I can get to a model of reasonable size, right? So that's kind of an indication. So I can get to a model with, again, I don't see from this angle, 69. Is it 69? 69 nodes and edges. Okay. And now the question is, okay, there is a hope that this model is good. Does it capture 80% of effects? Right. So this is 20% of causes. Does it capture 80% of effects? Next slide, please. So here you see this model now captured as DFG, 20% of paths. On the right-hand side looks reasonable. Maybe we can analyze and understand the process and take some decisions on how to improve the process. But on the left-hand side, I show you conformance information. So we call these artifacts alignments. So these sequences of chevrons, they're alignments. So if you see one line of chevrons, this is an alignment between a trace in my event log and a process model. So if a chevron is blue, it means there is a match. If there is a red chevron, it means there is no alignment. So kind of we get the promise. If I count from the top, first trace, misaligned, there are deviations, second, there are deviations, fifth, 4 blue chevrons, yeah, it aligns. The model describes this trace well. But I mean, I don't know. I hope you don't agree with me that we can, based on this analytics, conclude that this model captures 80% of the behavior or that happens in the process. And this is a problem. And this is a problem I'll try to address and kind of share with you some ideas how we try to address. So our goal is to construct models which can represent behavior more accurately, right? So that we can really say that, well, small share of causes captures large share of effects. Okay, next slide, please. So now I'll have a couple of slides where I'll try to replicate my eureka moment, right? So as a researchers, scientists, we sometimes have these eureka moments, and this is how the idea came to me, is that we can do process mining bottom up, and I'll explain what it means actually to do it bottom up. So I teach actually to my students complex systems, and a complex system is a system composed of components that interact, and this system has properties that none of the components has. None of components of the system has. Some examples. So Russell Eckhoff, who is the father of system thinking, he gives this example of human body. So human body is a complex system. We're body composed of parts, head, hands, legs, I don't know, brain, etc., etc. And so I hope you agree that these components interact, and none of these parts, none of these components has a property of life. Russell Eckhoff says it's easy to convince yourself in this. Chop off your hand, put it on a table, and see what it does. It does nothing. It has no life. Another example, automobile. Automobile can take you from point A to B. None of parts of the automobile can take you from point A to B. The engine itself will not take you from point A to B. Organizations, I hope you agree, they are naturally complex systems. They're composed of agents that interact to produce certain effects. Academia, universities, education is a side effect of a university, which is not possible to deliver just by components of university, right? If the lecturer is alone in a lecture room, education is not happening. If students come and there is no lecturer, education is not happening. If an AV team doesn't do a proper job, it actually spoils the effect of education. All right, so these are complex systems. And when we design complex systems, we can take two approaches. Next slide, please. The first approach, we can go top down. And again, I use some examples that I share with my students. When we go top down approach, we capture the system, we describe a system in terms of global states of a system. So we say, okay, we understand and appreciate that the system is composed of components that interact, but we abstract from these details and describe a system in terms of a global state of the system. For example, if I describe a population of people, of animals, I can be describing components and their interactions, but I can say, I abstract from these details, I'm saying this is a population of 1,000 individuals. So my global state, my global information about individuals is that I have 1,000 individuals, that's it. And then I try to describe dynamics of the system in terms of changes in this global state. So here I show you some examples of models how population growth is captured. And from left to right, they go in the level of complexity. And they become more and more complex once they try to reflect reality closer and closer. All right, so on the left-hand side, you have a simple exponential model where I say the population at time t plus 1 is equal population at current time point t times certain factor. This is unrealistic. It's exponential growth. If for example, population doubles every year, it doubles, well, we will soon just run out of space, food, and that's it. Right? So it's unrealistic. Logistic model is a bit more realistic model because it accounts for negative feedback. So, I mean, it accounts for limitations of space, food, etc. Next model, with predator-prey model. So we say now we can have more than one species. We can have predators and prey, and you know, sometimes predators eat prey and they interact in that way. And you see the equations become more complex, and so on and so forth. Next, click, please. And that's my argument. That's what we observe in spaghetti models when we do classical case-based process mining. We develop models which operate in terms of global state of the process, and then they describe rules about the evolution of the global state. And because reality is so complex, we increase the complexity of a model, the more rules we try to introduce to the model. So, but when we try to reflect the model closer to reality. So what is an alternative? Next slide. An alternative is to go bottom up in a different way. So not to model a system in terms of global state and state transitions between global states, but concentrate on modeling in those components and how they interact, and then build a system of these components, interaction structure, and let it go, simulate what happens. And I mean, again, I use example from my lectures. So classical archetypal example of bottom-up approach is game of life. So it's a archetypal example of an agent system. So I mean, in a game of life, you have a grid of cells, living cells. They can be in each cell can be in 2 states, on or off. So black is on, white is off, or alive, dead, if you wish. And kind of there are 4 rules, only 4 rules or principles how these cells operate. So loneliness rule says if my cell is lonely, if it has less than 2 neighbors, it dies in the next time point. Overcrowding says if my cell, and now again the focus is the cell in the middle, the black cell in the middle. If cell is overcrowded, if it has more than 3 neighbors, I mean it has no enough resources, it dies the next time point. Survival, if my cell has now I may be wrong, 2 or 3 I think neighbors, it survives. Reproduction, if a cell is dead and it has exactly 3 neighbors, it comes alive in the next time point. Okay, so that's it. That's what I describe about my agents, and this is kind of the simplest form of agent. A cell is an agent, has just on and off state. That's very simple representation. It can interact with neighbors and make decisions. Should I go alive from that state or should I die? There's a decision that kind of happens. And now we can compose these cells together, these agents, and see what happens. Next slide. Here you see a simulation where I have now many cells. So this is kind of the beautiful pictures that these cells can produce when working together. And you see that these simple rules all of a sudden demonstrate quite complex patterns, right? Kind of you may see some stable structures like here, for example, and they stay stable until some mobile components interact with them, and so on and so forth. And you say, yeah, this is very kind of chaotic. Can we control it? And yeah, you can control it. Next slide. So for example, on this slide, you see what is known Gauss-per-Gun configuration of these cells. So you see that this model kind of goes in a loop and produces those mobile components, gliders, that you see are running towards the bottom right corner, right? So you can actually control and implement reasonable logic, and actually this model is what we say is Turing complete. So it actually is capable of universal computation. Even this simplistic model can be used to describe any algorithm, any logic. And it can be actually even simpler. What you need to be Turing complete, you need actually just one-dimensional grid and cells which look only to the left and to the right neighbor. That's enough to have expressive power to express any logic. All right, next slide. So here comes the main idea of bottom-up process mining. We start with the event log, and instead of building a process model, we build a system. We try to find those agents, those models of agents, and put them in the right structure and build the interaction links. So this is a system of interacting agents, and we hope that the system can be simple, can be small, but can explain more causes that the classical process mining can, more effects than the classical process mining is doing. So if we simulate this model, it will be able to produce that spaghetti. And here I use a process model. The process model actually generates behavior which is even more spaghetti. This is just abstraction of the whole behavior the model can do. So this is kind of the basic idea, main idea of bottom-up process mining, or as we also call it, agent system mining. So now, the last part of my talk, can it help? Right? I mean, can it bring value? Okay, so next slide, please. So of course, to kind of look into that, we need to take a different perspective on the event log. So Will went into object-centric direction. He said cases, and these three attributes of case, timestamp, action is not enough. Agree. And you can be much more expressive, and you can build richer models if you use more information. What we will do now, we will use additional attribute, right? Additional attribute of agent that triggered that action that then later triggered the event that we see in a data set. And then we will also kind of then take a different perspective on the data set. So we will say, you see that green case 1, starts with 3 events or 3 actions done by Jane, by one agent, and then that case continues by 3 actions that were done by Jack. Right? So then we look at these episodes and actions of each of the agents, and then we also that becomes our unit of analysis. So not the case, but that episode of one agent working on a case. And right, so this becomes information about what agents are doing and interactions. I mean, we can infer some interactions. For example, right, so you see that handover arc. So once Jane passes work to Jack, that's a handover interaction. Next slide. So we built our algorithm, first algorithm, we called it agent miner with Andre, one of my PhD students, and a broader team. And that algorithm, what it does, it constructs first a model of interactions. So here you see the model of interactions that we constructed from that BPI Challenge 2014 log, right? Same log I showed before, activity log for incidents. 3 agent types, A1, A2, A3. This is the outcome we got. Next slide. And then we try to understand what those agents are doing, right? So there are 3 types. Then we take these, episodes of Jack and Jane and Jill, and we construct models of what those agents are actually doing. So we see that, okay, the orange agent is just doing 1 action, purple agent is doing just 1 action, green agent is a difficult agent, does a lot of things in a very difficult and complex manner. So, I mean, this by itself provides a new perspective into the process, right? So now you can all of a sudden understand what your intelligent agents or active components are doing. You can try to understand that and try to come up with recommendations of how you can improve that. Okay, next slide. So we took conventional process mining techniques, case-based techniques that rely only on 3 attributes, and we tried to build the best competitor models to what you saw on the previous slide. So here you see a model constructed by inductive miner. Inductive miner is one of the leading algorithms. Many tool vendors use these algorithms to discover models. So we constructed models, and this is the best model that can compare to the model I showed you on the previous slide. So here you see that it actually, reflects process. Well, it actually is, in this case, worse in all the 3 dimensions, right? It's larger in size, and its precision and recall is lower, right? So those quality criteria that I told you, they are lower. Next slide, please. So to find this best competitor model, right, we did a thorough analysis. So here you see that work we did with another student, Chintan, he's also here in the room. So we try different ways to identify agent types. So this AM is a classical, is original agent miner technique, BME, A matrix, and so on and so forth. These are different ways of identifying agent types. IM stands for inductive miner. Inductive miner has 1 configuration parameter, noise, filter, and threshold. We varied that from 0 to 1 in a step of 0.02. We constructed 50 models that inductive miner can produce. And here we plot, precision and recall, right? We try to understand which models on the Pareto front. So those that are in red circles, these are the models I showed to you. And again, repeating the precision, recall, and size measurements. So kind of, I hope I can convince you that there is a potential, right? This for us is evidence that this bottom-up approach and this way of discovering agents and building systems of agents can bring new value and can give interesting models that we can construct. All right. Next slide. So and now pure scientific curiosity, right? And this is all ongoing work. So we thought, okay, this green agent is very complicated. What is actually that the green agent is doing? And actually, the process is quite simple. If you describe it in a declarative way, what that green agent is doing, they start a So they start, and sorry, I don't think I have a mappings of those AOC short names on this slide, but this is referred to those actions. So the process starts by doing, so green agent starts, and first they do A, O, or C actions, so some of those 3 green actions, and then they can do any actions, that green actions, so sorry, except of A, so no, they can do A, so they cannot do O afterwards, and they can do them in any order, repeating them that, with only exception if you see X afterwards, you cannot see S, so action S. So basically, in the declarative way of expressing it, that process is quite simple. So this also gives a potential for mixing different paradigms when you do process discovery. Next slide. So here we just by hand, this is just purely by hand out of curiosity, we captured the model, right? We captured that principle in an imperative way in a PetriNet, and then we said, okay, with the same precision in the code, because those qualities stay the same, the model still captures same behavior, we can decrease the size even up to 54 elements. So right, we started with 300, then we saw 166. You can describe this model as well with a size of model of 54. So this causes, this small number of causes describes exactly the same number of effects that you see in the data. And maybe, sorry, I forgot to mention one thing. Can you go a couple of slides back? Right, so sorry, next slide. So here you see that there are colorful actions, and these are the actions that are actually used in an agent model that we constructed. The gray ones, they're picked up by inductive miner, while they're ignored by agent miner, because, well, they're not necessary to get to that level of precision in recalling your model. So this decision to include them as causes of all the effects, I mean, maybe not necessarily the best choice in this case. Okay, let's go. Next slide, next slide. So conclusions, last slide. I don't know, I hope I gave you a different perspective of what is possible in process mining. So again, the starting point is kind of similar to object-centric mining, very similar, in the sense that, well, if you just use case identifiers, activities, actions, and timestamps, it's not enough. I mean, you can do better. We use additional information. We use agent information, and you may be wondering, is this information available? And in datasets, often we have resource IDs, and we know that these are the elements that were involved in the execution of those actions, and we use them. We use those resource IDs in existing datasets as if they are agents. So we just do an assumption that they're agents. We really don't know for sure that they're agents, but still we get certain effects that I showed to you. So agent mining, in my opinion, complements conventional process mining. So I show you a data set where agent miner was working nicely. It's not always the case. In a wider experiment, we observed that roughly 50-50. In 50% agent miner gives some additional value. In 50% of cases, conventional process mining provides value. Gives a different perspective, right? So the main goal of process mining is to understand what's happening in your process so you can improve it. Now we give a perspective. You try to understand what your active components are doing in your process. So the goal is now you can, with that understanding, go and improve what your agents are doing. If you do such a discovery, right? I showed you that the model with green agent, orange agent, and purple agent. If you have such a decomposition of your work on agents, you can then consider which of those agents can be potentially replaced by agentic AI, or you can think of redesigns of your system of agents so that it works now also with agents, agentic AI agents. And I showed you these agents. They have decision structure, so you saw branches, also decisions, and you can further enhance these models by, for example, using object-centric event data to discover automatically not only the structure of decisions your agents are taking, but also actual rules according to which agents are taking decisions. I think that's the last point I wanted to make in this set of slides. Thank you for your attention. I think we are over time. Maybe one question, and then we will move to the next. If you have one immediate question, yes, Will, please. Okay, very good. Please.
Like it's an interesting approach, but the part where I disagreed was something that you showed in the beginning, where you were where you were doing the first experiment.
Yeah.
So, like you want to have a Pareto distribution. If you don't have a Pareto distribution, then filtering is not going to help you, right? So you want to have a distribution where there's a clear, like where the top 20 variants is explaining 80% of the behavior. And in the data set that you did, there was not this distribution. But you could have created that distribution by first just looking at the activities, right? The activity frequency probably has a Pareto distribution. And then first filter on the activities using the Pareto distribution. And from my experiences, then the variants also after that get a Pareto distribution, right? So you do a two-phase. And it may be that you end up with exactly the same model.
Okay, I agree. I agree.
Because if you look at your example, you get rid of all the low frequent activities. And by that, you can focus on the dominant behavior.
But we give the same chance of getting rid of infrequent activities also to, you know, conventional process mining, in the same way.
But you should first filter using this Pareto distribution argument.
Oh.
So the inductive mining, if you have this one parameter, is not doing that. Yeah.
Right. But okay. So maybe the data set has no Pareto distribution. I mean, we wanted to keep the original data set, and maybe we can modify it, you know, what you said, and then kind of get to Pareto distribution. But also the point is coming back to what you said, right? When you had a 20% model and that spaghetti model on one slide, you said, it's not the best way to go forward if you ignore those 20%, right?
Yeah.
Because many interesting things are happening within those 20%, right? In those low frequency data.
Yeah.
And if we can, in a model of a small size, simple model, capture more of the behavior, so have larger precision and larger recall, we are reflecting that long tail of behavior also better, providing better opportunities to take decisions, right?
I agree that there are these possibilities, but in your experiments, you're getting, in your approach, rid of the low frequent activities, and in the other approach, not. Right? But you could have also created that effect by filtering first on activities.
I'm not sure I see this. Maybe let's have a discussion.
Inductive miner just looks at the directly follows graph, which is complete, right? And that's not the best way.
So right, I need to kind of also maybe repeat a bit. So I'm not right. We saw the added value at this stage. It's possible to get the added value in a certain way you do things. And maybe there are other ways where you will not see value. We also saw examples where we didn't see value. So what the claim is that we can complement what we're currently doing with these techniques to get a new perspective, right?
We can discuss later.
Let's discuss. Thank you. Thank you. And Poornima? Sorry, I guess we are off the schedule a bit. Thank you for staying with us.
Hi, everyone. I won't take much time, maybe just 5 or 10 minutes. I'm sure you're already inspired by Will's and Artem's talk. And if there are students here who are now considering or would like to do your project or thesis on process mining topic, I just wanted to quickly introduce this program to you that we have as part of Celonis. So I'm Poornima, and I've come all the way from Bangalore, and I'm part of the academic alliance to our academic platform. Every student gets free access. You get access to our learning programs. You get access to a research-related program, which Will has delivered the program himself. You get access to the Celonis student community and the larger community, where if you're having any questions, you can interact with them and get answers for that. And where possible or where it is really relevant, we also provide something called as extended support or further support, where we can enhance or provide you certain functionality which might not be there in the first version of the academic license that you get. We also enable interviews with Celonauts, and there's a lot of other support that we give as well. Next slide, please. So just a couple of examples of what we have done with thesis students. Next slide. So this is one example where we were looking to develop a new process discovery algorithm, and jointly with Aachen University, the project began as a joint master thesis project in 2022. In 2023, there was a joint patent that was filed, and there was also, it was published and presented as part of ICPM in 2023. And in 2025, this discovery algorithm, process discovery algorithm, was incorporated into the Celonis product. So this is just an example where it began as a thesis project and ended up as part of the product. Next slide, please. So this is where we worked along. This is an example which helped us increase user adoption and user experience with Celonis. And this was done along with Vienna University and also one of our customers who was having a challenge where, they had purchased Celonis, but there was a challenge with user adoption because the users thought it was too complex, or there was not enough rewards to use it, or, in generally, employees, they resist change, right? Or user adoption to a new product is always a bit difficult. So here, what we did in collaboration with Vienna University and a customer was we gamified the entire approach to usage of Celonis. And the outcome was that there was higher engagement, There was knowledge sharing across all the employees or the users who were using Celonis. And there was a self-sustained adoption of Celonis as well. So these are just two examples. We work with a lot of students on different topics, like, right from developing new algorithms, on sustainability, on community, on education, a lot of different topics. Next slide, please. So yeah, if you have friends, or if you are interested, if your friends or colleagues or anyone is interested in doing your thesis or project or seminar, or it could be anything on Celonis, you can just sign up to our program, and you will get information about this on the Celonis website as well. You just register for it, and you will get all the details that you need to help with your thesis or your project study. So that's it from me. Any questions? Yeah.
Also, the student here, if they join the program, and we know that Celonis is much more active in the Europe side. So, for example, if as a Australian students, is there any chance moving after the program moving into Celonis? Is that like an expansion in Australia? Is that the plan, or is it something that?
So this is a global program. Right. So any student from any country can sign up, irrespective of their university or where they come from. As long as the topic is process mining, right? Because the platform that you're getting is Celonis. We don't have any facility where you do your thesis with Celonis and you can join Celonis, but we do have couple of programs called Galaxy program and Orbit program, depending on which role you're wanting to get into, which you can definitely explore, and you can get in. In Australia, we set up a Celonis team only last year. It is a very small team right now, but yeah, should grow quite rapidly. We do have, there were some people here. We do want to bring in opportunities where we can take, graduates right out of university into Celonis, but it will take, maybe a year or so for that.
Thanks.
Yeah. So perhaps to add to that, I think that that you should think about your employability in the end, right? So I think if you do these things, and I think the goal of such a program is not to drag people necessarily directly into Celonis, right? That can happen. But what you see is that there are many jobs that are on the interplay of process and data, and they may not always be labeled as process mining. Like I was just, I had a lunch with most of the consultancy firms that are here in Melbourne, and they are screaming for people that have like strong data science skills combined with this process element, which is often missing. So I think from an employability point of view, I think these things are very interesting. Yeah.
Yeah. So to just add on to what Will said, usually I have a presentation on what we do as Academic Alliance, a little bit on Celonis as well. So we work with almost, I think, 300 plus partners globally. And the big four consultancy firms are our partners. Many of the service providers also partner with Celonis. So yeah, the job opportunities are immense. And we have almost like 1,400 plus customers, again, globally. Like I said, we just set up market here in Australia. We already have 3-4 customers. So the job opportunity is everywhere. It's not just with Celonis. And again, in Will's Gartner report, he showed so many other vendors who also provide similar kind of technology, right? So once you have the foundations, you can get in anywhere.
I'm a practitioner, 30 years in consulting, and I work for the big firms as well. One of the challenges, it's a new tool to me. In fact, I just got introduced to it. It's very, very exciting. I have done so many projects, not all of them are process projects, but whenever I do it, I'm always wanting tools and it's hard to get access to it. Is this open for people like me?
Yes.
Yeah, I just want to use it, and you'll have 100 questions and you use it of real world and how it's actually used in the thing. Is that open?
Yeah, you can sign up as long as you sign up as a student and a learner,
Yes.
you can use it.
Thank you.
Any other questions? Okay. Thank you. Thanks for your time. I think that was a lot of food for thought. And yeah, please join us. And yeah, you can speak to Will and me and Artem if you have further questions. Thank you.